On July 1st, 2025, a telescope in the Chilean desert flagged a point of light moving in a way nothing in our solar system moves. It wasn't orbiting the sun, it was passing through. Only the third object, like it ever confirmed in human history. Then, in August, James Webb turned its infrared eye toward it. And what came back didn't calm the mystery. It split the world's astronomers into two camps that still haven't stopped arguing. One side says ice, dust, and gas. The other side says something else entirely. Tonight, we go through the data NASA is still quietly trying to explain, and we ask the question nobody has fully closed the book on. What is 3i Atlas, and why does one of Harvard's most credentialed scientists refuse to call it a comet? It started as a smudge of light nobody was looking for. The Atlas Survey Telescope in Chile, a system built to catch asteroids on collision courses with Earth, picked up something moving too fast, on a path too straight, to belong to us. Within days, orbital calculations confirmed what the early numbers had hinted at. This object wasn't looping the sun the way every comet and asteroid native to our solar system does. It was slicing through on a hyperbolic trajectory, arriving from somewhere else, and it was never coming back. Astronomers gave it a name that sounds almost bureaucratic for something this rare: 3i Atlas. The 3i matters more than people realize. It means this is only the third interstellar object ever confirmed crossing through our solar system in the entire history of astronomy. Not the third this year, the third, period. Before it, there was Oumuamua in 2017, a strange, tumbling, elongated body that left more questions than answers. Then Borisov in 2019, which behaved more like a familiar comet. Now this. And almost immediately, scientists noticed something that set 3i Atlas apart from both of its predecessors. But to understand why, that mattered. You first need to understand just how much firepower got pointed at this one small object. Because here's what most people never heard about. NASA didn't just glance at 3i Atlas. It mobilized Hubble, James Webb, the TESS planet-hunting satellite, the Swift Observatory, the newly launched Spherix mission. Even spacecraft that had no business being involved got pulled in. The Perseverance rover on Mars, the Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, the Parker Solar Probe, even the solar-watching SOHO satellite. Read that again. More than a dozen separate space assets spread across the solar system, all turned toward a single wandering visitor smaller than a mountain. That is not the level of attention you give a routine comet. That is the level of attention you give something you're not entirely sure about yet. And the agency doing the watching wasn't hiding its interest. Officials openly said the object posed no threat to Earth, closest approach nearly 170 million miles away. So, if it wasn't dangerous, why did it deserve this much attention? That question is where the real story begins. The first serious answer came on August 6, 2025, when James Webb pointed its near-infrared spectrograph at the object. This wasn't easy. 3i Atlas was moving fast, and Webb's instrument has an extremely narrow field of view. Engineers had to calculate its trajectory with near-perfect precision just to keep the object inside frame. But when the data came back, it revealed something researchers weren't fully prepared for. The coma surrounding the nucleus, the cloud of gas and dust that comets release as they're warmed by sunlight, was dominated by carbon dioxide to a degree rarely seen. The ratio of carbon dioxide to water in that coma came out to roughly 7.6 to 1. To put that in perspective, that ratio sits more than 4.5 standard deviations above the normal trend line for comets at that distance from the sun. In plain language, this is one of the most carbon dioxide-rich comets ever measured, at any point in recorded astronomical history. And that number alone should have been the end of the story. It wasn't even close. Because once researchers dug deeper into the spectrum, they found more: water vapor, carbon monoxide, actual water ice, not just vapor, fine dust, a tentative trace of a rarer compound called carbonyl sulfide. Each new molecule filled in another piece of a chemical, fingerprint unlike anything from our own solar system's comet population. But here's where it gets worse, or better, depending on how you look at it. In December, months after that first observation, Webb went back for a second look, this time using a different instrument, the mid-infrared instrument, MIRI. And in that second pass, right around the time the comet had swung past the sun and it was heading back out into deep space, Webb detected something that had never been confirmed on an interstellar object before. Methane. Actual methane gas escaping from the nucleus in measurable quantities and at a ratio relative to water that stood out compared to typical solar system comets. This was the first time in the history of astronomy that methane had been chemically confirmed, venting off an object that formed around another star. Think about what that means. Every comet we've ever studied up close came from our own solar system's birth. This one didn't. and it was carrying a chemical signature that hinted at conditions radically different from anything the sun's planetary disk ever produced. So naturally, scientists started asking, how old is this thing and where did it actually come from? A preprint analysis, still working its way through peer review, proposed something that, if confirmed, reframes the entire object. Based on its trajectory and the environment it likely formed in, some researchers estimated 3I Atlas could be somewhere between 10 and 12 billion years old. Let that sit for a second. Our sun is 4.6 billion years old. Earth is younger than that. This comet, if the estimate holds, could be more than twice the age of our entire solar system, formed in a cold, distant pocket of the Milky Way when the galaxy itself was still young, potentially within just a couple of billion years of the universe's own birth. You are not looking at a leftover chunk of solar system debris. You are looking at something that may have been drifting through the galaxy since before most of the stars in the sky tonight had even ignited. And that is exactly the moment this story stopped being purely about chemistry and started being about something much harder to prove or disprove. Because one man looked at the same data everyone else was looking at and refused to accept the quiet, comfortable explanation. Avi Loeb, a Harvard astrophysicist with a long decorated career, began publicly arguing that 3I Atlas might not be a natural object at all. His case rested on a handful of specific anomalies. First, the object displayed what's called an anti-tail, a jet of material pointing directly toward the sun rather than away from it, the direction cometary tails are supposed to point due to solar wind and radiation pressure. Second, later Hubble imaging revealed 3 smaller jets, positioned with what Loeb described as unusually precise symmetry, roughly 120 degrees apart from one another, like spokes on a wheel. His argument was simple and deliberately provocative. Nature doesn't tend to produce that kind of clean, engineered-looking symmetry. Comets are supposed to be messy, lopsided, chaotic, the way a half-melted block of dirty ice behaves when it's randomly rotating and outgassing unevenly. So why, Loeb asked, did this one look almost designed? And this is where everything changes, because for the first time, a credentialed mainstream scientist wasn't just entertaining the alien hypothesis as a thought experiment. He was building a public case for it, paper after paper, blog post after blog post, refusing to let the conversation die quietly. What most people are not seeing, though, is how forcefully the rest of the scientific community pushed back, and how quickly. Researchers who'd been tracking 3I Atlas since its discovery pointed to a simpler, less dramatic explanation for nearly everything Loeb raised. Yes, the coma was carbon dioxide rich, but comets with unusual chemical ratios exist even within our own solar system. Rare, but not unprecedented. Yes, the jets showed some symmetry, but rotating nuclei with pockets of surface ice can produce jets that appear periodic and structured purely through geometry and heat conduction. No engineering required. The consensus statement from the researchers who'd studied it most closely was blunt. Unlike Oumuamua, which was strange enough to genuinely puzzle astronomers back in 2017, 3I Atlas displayed what they called mostly typical cometary characteristics. A visible coma, a tail, a nucleus that wasn't dramatically elongated or tumbling erratically. Their conclusion, in their own published words, was that there was currently no evidence 3I Atlas, or any interstellar object observed so far, was anything other than a natural astrophysical body. But, and this is the sentence that kept the story alive, they also admitted something else. With only 3 interstellar objects ever confirmed crossing our solar system, the sample size is so small that thorough study is warranted before anyone closes the case completely. Read that again. Even the scientists debunking the alien theory refused to say the door was fully shut. So they didn't just argue about it, they tested it. This is the part of the story that almost nobody outside the astronomy community heard about, and it might be the most dramatic turn in the entire saga. Researchers from the SETI Institute and the Breakthrough pointed massive radio telescopes directly at 3I Atlas. First the Green Bank telescope in January 2026, then months later, the Allen Telescope Array, a 42-dish interferometer in Northern California, and a study published in June 2026. What were they listening for? Narrowband radio signals, a very specific, focused type of transmission that natural cosmic processes almost never produce, but that artificial technology does. If 3I Atlas really was some kind of ancient alien probe drifting silently through the solar system, a signal like this would be one of the clearest possible giveaways. The first data pass from these searches flagged roughly 470,000 potentially artificial-looking signals. For a moment, imagine being the researcher watching that number climb. Then comes the deflation, methodical and unglamorous. Nearly every single one of those signals also appeared when the telescope was pointed away from the object, meaning they were just Earth-based interference. Cell towers, satellites, background radio noise. The handful of remaining candidates were checked and ruled out as human-made as well. 2 separate research teams, using 2 different instruments at 2 different points during the flyby, reached the exact same conclusion. No credible artificial signal, no technosignature, nothing. And yet, that didn't end the argument either, because the size of the object itself became its own quiet controversy. Early, measurements using Hubble suggested the solid nucleus at the heart of all that gas and dust was small, under a kilometer across, smaller than many mountains on Earth. But newer analysis, pushed forward by Loeb and a handful of collaborators, argued the true nucleus might be significantly larger than that initial estimate, based on how much material it was releasing and how bright it appeared relative to typical cometary activity. Why does size matter so much here? Because a small, unremarkable nucleus fits comfortably inside the just an ancient comet explanation. A surprisingly large, dense nucleus producing that much gas raises harder questions about what exactly is powering all that activity, and whether the standard models for how comets behave near the sun are even the right framework to apply to something this old, this far traveled, and this chemically unusual. Neither side has fully won that argument. The data remains, by most honest accounts, messier than either camp wants to admit publicly. Meanwhile, the object itself never stopped moving, indifferent to all the arguments happening about it back on Earth. It made its closest approach to the Sun on October 30th, 2025, swinging through at a distance just inside the orbit of Mars. Close enough for intense solar heating to trigger the outgassing that produced all of that chemical drama, but never remotely close enough to threaten Earth. Its nearest pass to our planet came in at around 170 million miles, a gap so vast it was never anything more than a distant curiosity to anyone worried about impact risk. By the middle of 2026, having slingshotted around the Sun, 3I Atlas was already well on its way back out, passing beyond the orbit of Jupiter, fading in brightness, shrinking in every telescope trained on it. And here's the part that should sit heavier than it usually does. This is a one-way trip. Interstellar objects like this don't loop back. They arrive once, swing past, and vanish into the dark for what is, for all practical purposes, forever. Whatever answers we were going to get from direct observation of 3I Atlas, we were only ever going to get them during this one narrow window. That window is now essentially closed, but the argument hasn't. As recently as this month, Avi Loeb has continued publishing near-daily commentary on interstellar objects, unidentified aerial phenomena, and the broader question of how humanity would even recognize alien technology if it were sitting right in front of us. His critics call it obsession chasing a headline. His supporters call it the only scientist willing to ask the uncomfortable question out loud. Consequences to his reputation be damned. Somewhere in Harvard's halls, the divide has reportedly become personal. Graduate students privately worry that entertaining weird questions publicly could cost them a career, while Loeb's own inbox fills with messages from ordinary people simply grateful someone in a lab coat is still willing to say, "What if?" And underneath all of it sits a genuinely unsettling thought raised by the very researchers who scanned 3I Atlas for alien signals and found nothing. One day, our own Voyager probes, drifting silently, permanently out of our solar system, will be the interstellar objects that some other civilization's telescopes catch passing through. If another species were watching us the way we watched 3I Atlas, would they see a comet? Or would they see something they couldn't quite explain either? So where does that leave us now that the object is gone and the data is essentially final? The overwhelming scientific consensus is that 3I Atlas was exactly what it looked like from the very beginning, an ancient interstellar comet, carrying chemistry shaped by a star system that may have existed and died long before our own sun ever ignited. But the questions Loeb raised were never fully answered so much as they were out-argued by probability and consensus, not conclusively disproven point by point. The symmetry in those jets, still debated. The size of that nucleus, still contested. And the deeper question underneath all of it has nothing to do with 3I Atlas specifically anymore. It's this. We've now had 3 confirmed interstellar visitors pass through our solar system in less than a decade, and our detection methods keep improving every single year. The next one could come sooner than anyone expects. Maybe next year, maybe next month. And when it does, will we recognize the difference between an ancient snowball drifting home from nowhere and something built by hands or minds we've never encountered? Because right now, honestly, we're not entirely sure we'd know the difference in time to matter.